I'd like to welcome everyone. This is one of a series of webinars organized by CESI, and today's topic is digitalization for net zero, how data platforms can support decision-making in an integrated energy system. My name is Harris Patsios. I'm an academic at Newcastle University and part of the CESI team. And today we'll have the pleasure of having two keynote talks on this very interesting topic. One is more from the academic side, and it's on decision support tools for the operation of public sector systems in the context of multi-energy. And the other one is on the industrial side, and it's on a specific platform developed by Siemens called your online data architecture platform. We will begin with the talk from two academics, Dr. Muditha Abeysekera from Cardiff University, and Dr. Sathsara Abeysinghe, again from Cardiff University. And this will be a joint talk. Now, I don't know if the first speakers are ready and can share their screens while I give some background information around them. I don't know. Alison, are you? Is it?
Yes, you should be able to share your screen.
Okay.
Sorry, I haven't.
Yep.
It's still disabled for screen sharing. I think you'll have to give access to screen sharing.
So while Alison is doing that, I'll say that Dr. Muditha Abeysekera is a lecturer in energy systems at Cardiff University. His research interests are in modeling, design, operation, and the study of socio-techno-economic impacts of smart local multi-vector energy systems. And Dr. Sathsara Abeysinghe is a postdoctoral research associate at the Center for Integrated Renewable Energy Generation and Supply at Cardiff University. She has received her Bachelor in Science degree in Electrical and Electronics Engineering from the University of Peradeniya, Sri Lanka, and her PhD in Electrical Engineering from Cardiff University. Her research activities focus on statistical assessment of energy distribution networks, analyzing the grid impact of low carbon technologies and the flexibility provision from decentralized energy resources. She's the principal investigator of a Flexible Fund project funded by CESI, titled A Decision Tool for Real-Time Operation of Public Sector Multi-Energy Systems, which is also going to be the main topic of the discussion today. So, Dr. Muditha, we're ready if you would like to go first.
Okay, thank you very much, Harris. Can you hear me okay?
Yes.
Okay, great. Okay, good afternoon, everyone, and thank you for the Center for Energy Systems Integration for inviting us to speak today at this webinar. And my name is Muditha Abeysekera, and as Harris mentioned, I'm a lecturer at the School of Engineering at Cardiff, and I will be joined by my colleague, Dr. Sathsara Abeysinghe. We both represent the Center for Integrated Renewable and Generation and Supply at Cardiff University. So what we really plan to do today is to briefly introduce our research that has been funded by the CESI Flex Fund projects, which aims to support the public sector in the challenges they face in the transition to decarbonization. And these projects are really short, very focused projects that we have been doing in collaboration with the UK Cabinet Office, the UK Power Networks, and a number of public sector partners. So let me start by giving some background. And of course, this is largely driven by the UK's net zero 2050 commitments that has passed laws to bring all greenhouse gas emissions to net zero by 2050. And interestingly, the public sector is expected to play a very central role in this transition. For example, the National Health Service, the NHS, has already committed to reducing their direct carbon emissions from their activities to net zero by 2040. So this was just announced a month ago. And the higher education sector, so this is university campuses, already has a commitment of 30% reduction by 2021, leading to 50% by 2030. And a number of the universities has committed to net zero as well. So you might have already seen this Declare a Climate Emergency platform. And if you log into there, you will see 245 local authorities have declared a climate emergency. And out of that, 149 have set a target of reaching zero emissions by 2030 or earlier. So this is really a significant challenge. So what do we mean by the public sector? And this involves the government estate made up of the hospitals, schools, prison complexes, business and innovation parks, administration offices, and many more local public sector assets that are spread all around the country. It was actually surprising for me to find when I started off this research that the public estate is the single largest buyer of electricity and gas in the UK outside of the big 6 energy suppliers. Sorry, for some reason the slides moved by themselves, sorry. So that's total of 6% of overall UK energy. And the UK government spends over £2 billion every year on its energy bill. So this shows the scale of the public sector role in our UK's energy system. And our interest in this really has been to look at what are called as the campus energy systems of public estate, which typically are the hospitals, university campuses, and these office and business parks, which have their own, which are large users of power and heat, and they typically own and operate an on-site energy system. So 2 case studies have been of our interest. So on the left-hand side, you see the technical arrangement of the energy supply system at Queen Elizabeth Hospital in King's Lynn. Interestingly, for a hospital, it has an 800 kilowatt wind turbine and on-site combined heat and power plants supported by the gas boilers for heat supply and electric chillers for cooling. So this is the arrangement, and often we'll talk more about this case study. Due to the wind turbine, there is often excess electricity than the site requires, leading to exporting electricity to the UKPN network. So this is one of our case study sites. Then the University of Warwick campus, which is the size of a typical UK town, where around 30,000 people live and go to work within this area, again has a very similar structure, but of course of a much larger scale. Here the renewables are mainly around 600 kilowatts of solar PV and 2 main energy centers containing around 9 megawatts of combined heat and power plants, a very large district heating network supplying most of the campus area, and some absorption cooling and district cooling networks that supply cooling. So these are the sort of campus energy systems of the public estates that has been the focus of our studies, and how to move these from today, where these are supplied by natural gas and CHPs, to the future. First of all, looking at the operation optimization, and then moving to the future net zero opportunities. So we held a workshop at the early stages of our project with bringing together public sector energy managers to discuss what are the challenges that they face in the day-to-day operation, and also the long-term vision for these sites. So these are a summary and a list of what these challenges were. So it was very common that energy system and the supply of energy was not their main priority. It is one of the priorities among others. System resilience, so having reliable electricity, heat, cooling was much more important than efficiency or the improvement of costs. So this is, you can imagine for a hospital, this is particularly the case. Most of these sites were having problems with aged infrastructure and obsolete equipment that they were struggling to maintain. And as you will recognize, there were lots of financial constraints and a lack of engagement with the energy system improvements, which has historically led to a lack of investment. And overall, there was a lack of an energy strategy. So now having this declared a climate emergency and committing to net zero targets, now this was becoming important to look at having an energy strategy for these organizations. On the more technical front, they were recognizing that having a combined heat and power plant is no longer carbon saving. So carbon reductions will not come from just having invested on a CHP. They were bombarded with suppliers asking them to put solar PV, battery storage, new fancy controls on their sites, which was getting a lot of, so there was a lot of challenges in order to decide which were the best fit. And there were conflicting systems as these new infrastructures were added. There were local DNO constraints which wouldn't allow them to connect renewables onto the sites, and of course the complexities and uncertainties in the energy sector that delayed the decision. So this was a really important recognition to the challenges faced by these public sector. However, having recognized this, it was agreed that these passive consumers of our energy system needs to move from being just consumers to a much more actively managed and sites with lots of generation, on-site generation of renewables, thermal and battery storage, and on-site energy conversion. And these sites will need to respond to the weather forecasts and electricity price fluctuations on the grid, and at the same time supporting the local grid in order to manage the constraints, in order to really move to an active distribution system. So the hypothesis was really that there was a clear need for decision support tools, and we had already done over a decade or so development of tools and methods to really analyze, optimize these type of systems, but there was a clear gap in translating our research to tools and platforms that were simple enough that for the practicing managers of these sites to engage with. So so this is what we were trying to address from both what we are, what me and Sathsara will talk about. So this led us to these two projects, which me and Sathsara will talk, which is the phase one of the project was to develop a decision support tool framework, which looked at a public sector sites in order to recognize the operation optimization opportunities of a single site. And this, we started with the operation and not the design, because this was the first step into this problem. And Sathsara will talk about the second phase, having recognized these savings and the opportunities, how we will implement them in real-time operation improvements. And this figure really shows the collaboration, and which was an important part of our project, which brought together the key stakeholders in addressing this problem. We had the government support from the Cabinet Office. We had the building management suppliers, which was integrated control solutions. We had the local DNO support, then research organizations, and of course the public sector sites, which brought together both these two projects. Okay, so let me get to some technical information about the projects and what we have achieved. So I will talk about the first project. So this site is the Queen Elizabeth Hospital in King's Lynn. And as I described, they have an 800 kilowatt wind turbine on site with 2 CHPs of 700 kilowatts each, supplemented by gas boilers for supplying the heating demand. The commercial arrangements for electricity and gas was very interesting, where they had commercial arrangements to both, because the wind there was owned by a separate entity. So the wind was bought by the hospital and any excess electricity was sold back when it was being exported to the grid. And then they had the traditional electricity import and the gas export rate. So this is what we were looking to actually study and optimize for the site, both from a carbon and cost point of view. Just to mention, they were constrained by this UKPN network capacity constraint of 200 kilowatts, which was restrictive because most of the time, the wind turbine plus the CHPs that were generating on site would exceed this 200 kilowatt capacity. And this leads to the CHPs being modulated much more than they would typically be used on such a site. So first project was really engaging with these sites and looking at data and using our already built models to apply and identify the opportunities for the savings in both energy costs and the carbon savings. So first, what we did was to really go and work with the site officers and collect historical data from the BMS systems, the energy suppliers for these sites. So these are a list of the data we collected, and for QEH and the Warwick case, we have half-hourly data for over 2 years worth. And then we recognized that it was very important for us to go beyond what we would use in our research to visualize to something that we could communicate the messages to the energy officers. So we put together this Microsoft Power BI dashboards and data platforms where we could, first of all, visualize the historical data, which gave us a lot of interesting insights as to how the site worked, what was going wrong at times when we had lots of wind output. So, and this was very interesting for the site operators and the managers, because this was the first time they started seeing all this data in a single platform. So if we have time, I can also show the actual platform we have developed. So this, and then the modeling part was we had MATLAB-based models, which modeled the energy supply systems for site, and we ran optimization for the historical data to show what were, and to show the comparison between what was actually realized on site based on the control systems of today, and what was the potential for the optimal operation and the improvements. So we were able to generate these sort of figures which could show at a half-hourly granularity what was the actual site costs, what was the optimal site costs if the optimal operation strategies were used, and therefore the cost savings. So these were sort of hourly profiles, and we aggregated them to actual the saving and then a total saving. So in some of the months we could see 10,000 pounds would be saved just in a sort of month of October, which would lead to around 15–20% of the site cost, which was huge when we think that this is really only changing the operation or the control of the site. So this is another visualization which was very engaging for communicating the messages, showing the real operation and what could have been achieved in a better optimized system. So these were the outcomes of the first stage of the project, which was a decision support tool looking at the site from a perfect foresight point of view using the historical data. And what were the outcomes? This led to providing evidence for the site and the energy officers, which were looking to upgrade their on-site BMS system, which was very old and couldn't use more sophisticated controls that we would require to achieve and realize the savings. This also led to providing evidence in support for negotiations with UKPN for a flexible grid connection, because we showed if that 200 kilowatt export constraint was released, there was significant economic and potentially carbon savings for the site and the local network. And which Sathsara will talk about next is we have now started working with the support of CESI on a new project, which we are trying to move from looking at the historical data and the perfect foresight assumption to actually realizing these savings in real time in the system. And we have been invited by the Rotherham Hospital to move and do a very similar exercise for the Rotherham Hospital using these tools. So I will at this point pass to Sathsara, who will discuss the second stage of the project.
Okay, thank you, Muditha. Can you give me the control of the slides?
I think I did say if you can move.
Okay, let me see if I have the control. Yeah, looks like I do. Okay, thank you again, Muditha, and good afternoon, everyone. So from this point onwards, I will talk about our CESI Stage 2 project, like Muditha said, in which we really try to implement the potential benefits that we identified from the CESI Stage 1 project. So essentially what we are going to do here in this project is to develop new control algorithms to improve the real-time operation of the public sector energy systems. And I need to mention that this is an ongoing project and we are just a few months into the project. So what I show here today are the key concepts that we proposed and also some of the developments and the results we've been able to achieve so far. So regarding the project organization, in order to achieve this objective of improving the real-time operation of the public sector energy systems, we've divided our work in under 4 key tasks. So like I said, we are going to propose new control algorithms for improve the operation. So in order to do that, first we need to identify the current operation of the public sector energy system, specifically on the 2 case study sites Muditha showed to you. One is a hospital site, the other one is the University of Warwick campus energy system. So by analyzing or by reviewing the current operation of these 2 case study sites, what we found out was that at the moment these energy systems are operated based on very simple rule sets. So there is a very big opportunity to introduce new control rule sets or new operational strategies to these energy management systems. And however, if you think about how we're going to actually see the performance of these new control algorithms, we cannot actually implement them on the real systems because they are critical infrastructures like hospitals and universities. And due to safety reasons, we cannot trial these new algorithms on the actual system. Because of that, as a second step, we are developing digital twins of these case study sites, and I will talk about this in a minute. And as the third step, having developed these digital twins, we will really move on to develop our new control algorithms to test on these digital twins. And finally, as the fourth step, we will run these new control algorithms on the 2 case study sites and will quantify the benefits of the real-time operation of these energy systems against the theoretical benefits we quantified in the CESI Stage 1 project. So in the next slide, sorry, I think, okay, thank you very much. So just to show the linking between the first stage project and the second stage project, I'm just here showing in the first stage project what we've done. So we had this large amount of historical data And based on that data, we could assume the perfect foresight of the energy systems, and the optimization results told us, depending on different combinations of the operational parameters, how the system should have operated to have the optimal benefits. And that was presented using an Excel-based decision support tool, and Muditha showed you the visualization. But however, in the second project, if you can go to the next slide, Muditha, what we are proposing is using these optimization outputs, which describes the optimal operating set points of the controllable energy assets based on different combinations of the input parameters, how we can really implement a new control logic rule set to replace the existing static rule set on the building energy management systems of the current public sector energy systems. Also, in terms of some other improvements, instead of using just the existing measurements like the demands and on-site generation, how we can use the price forecasts, the weather forecasts to dynamically do some optimization and calculate improved control set points for the controllable energy assets. The next slide, please. Yeah. So this slide shows our concept of the digital twins to trial these new control algorithms. So digital twin essentially in our project is a digital replica of the actual energy systems. So in the blue boxes here, we are showing the components of the real energy systems. There are external conditions like the seasonality, the day of the week and time of the day, and ambient weather conditions that affects the energy consumptions of the buildings together with the building occupancy. And based on that, the building energy management systems, the PLCs in the building energy management systems, they give some controls logic to the controllable energy assets. And then based on the operation of the energy assets, the electricity and the thermal system behavior of these energy systems are defined. So corresponding to each of these blocks we show in blue color, we can implement a digital replica in a simulation platform to implement our digital twin. So the external conditions can be emulated in the simulation environment, and also we can use historical data or trained model to emulate the building occupancy and also the electricity and heat demands of the energy systems. And then by analyzing thoroughly the existing controls of the PLCs in the current energy systems, we can replicate those controls using a software code as shown in this yellow box. And then we can use this computer coded the control logics to control the functional blocks that represents the energy assets of the energy systems. And then finally, we can give this into a mathematical model, which is an energy hub model in this case for our research, to model the system behavior. So essentially our research area for this CESI focused research is this highlighted box. So what we are going to implement to replace this software code that is existing in the current energy systems with new controls rule sets. Can you go to the next slide, Muditha? Yes. So just expanding that yellow box where I showed the current controls, this one is for the case of the Queen Elizabeth system, energy system. So with regards to the current controls, in the PLC, we have a master controller and then some child controllers to control the controllable energy assets like the CHP units and the boilers. And these are at the moment a static rule set. So in our this current project, what we are going to propose is to replace this existing rule set with new improved rule set using the existing inputs, or as a second step, use additional measurements like the energy prices and the weather forecasts and replace the existing rule set for forecast. Also do some dynamic optimizations to give more optimized control logics or control rules for the energy system. So this slide shows some of the initial results for validation of our digital twin. The left-hand side figure shows the how the historical data shows the operation of 2 CHP units to meet the electricity demand that's shown in this black line on the stacked graph. And the right-hand side figure shows how the digital twin gave commands to the CHP units to operate to satisfy the electricity demand. So you can see a good match between the historical data, the operation of CHP units, and what we got out of the digital twin. So at the moment, we are doing some developments for that. And finally, moving to the next slide, while we are trialing our new control algorithms on the digital twin, we are also implementing a hardware and software test bed to test the new control algorithms. So we've purchased some PLC controllers, and what we are trying to do here is emulate the system conditions using the historical data and use some forecasting models to forecast the weather, energy and energy demands, etc., to really trial how this kind of real-time, the algorithms would work for real-time optimization of the energy systems. So as key takeaway points, I can again emphasize that public sector has a great potential to lead the decarbonization agenda for the UK. And also there is a clear need of decision support tools for the public sector energy systems. And also the data requirement is huge for achieving this kind of goals. So that's all from me today. Thank you very much for listening.
Right. Thank you very much to Dr. Abeysekera and Dr. Abeysinghe for the very interesting talks. Now we will hold questions until the final final item in the agenda. So I'll hand over to Andrew Smyth, who's head of customer success software, Siemens. And Andrew, are you able to share
I
screen?
think so. If you bear with me just 2 moments, I'll let my cell phone or technology come through. So hopefully you can see my screen there.
Yes, that's great. So I'll make a small introduction. Andrew has been with Siemens for just under a decade, in which time focusing on project and program delivery of innovation initiatives throughout the power networks for Siemens Digital Grid. More recently, Andrew has moved into the digital grid software business, leading the meter data management and grid edge portfolios. As part of this role, Andrew is now responsible for Siemens Modernising energy data access, MEDA response, understanding how data and digitalization can enable a pathway to net zero. So Andrew, over to you.
Thanks very much, to Harris. And apologies, I've just got a note there saying my internet connection is not particularly stable, so please bear with me if we do have any blips. But it's really interesting to hear there in terms of some of the takeaways from the project, which the colleagues had just mentioned, in terms of the value and need for good quality energy data. And that really aligns very well with the concept of the Modernising Energy Data Access Call, which is run by Innovate UK, with full support of UK government, BEIS, Ofgem, the ENA, and all key energy sector stakeholders. So for a little bit of context, MEDA, as it's known, is a competition which has been running now for a period of months, starting in December last year. With COVID, the initial kickoff was delayed somewhat, but Siemens were one of 3 organisations who had successfully entered this competition. We called our offering Your Online Digital Architecture, and over the course of the last 6 months, we've really been developing, engaging with stakeholders of all types within the energy sector, and really creating a vision and a prototype now as to how we would enable increased levels of open data access within the energy sector. So really just unpicking again, why are we doing this? We fundamentally see that there is a problem of exchanging digital energy information between 2 succinct different types of individuals, data providers and data users. And our aspiration is really to look at how we can create an energy data service. This one facilitates increased levels of transparency of energy data, but also then enables increased levels of data access and exchange. We fundamentally believe that there is a problem with understanding what's already there, regardless of what's coming down the track with respect to a much wider digitalization agenda. So understanding the current energy data landscape is critically important to allow us to have a successful base to move upon as digitalization topics progress at speed over the coming years and decades. So we are currently in our 2nd phase of the program, what's called Alpha, and during this session, during this stage of the program, we're really tasked with developing an initial prototype for the platform. Now, our approach in doing this, we looked at 3 core work streams. Workstream 1, which we called Insight and Exchange, is really continuing to understand and speak with customers and stakeholders to see how they would want to interact, share data, use data within such an open data platform. The principles of open data are great. However, there is also the technical requirements around data licensing and the framework conditions which are appendix to the provision and access to data owned by various different organizations. And other hygiene factors which sit much broader across in terms of governance, standards and things like that. And we're trying to address, or at least start to unpick, a lot of these topics within this first work stream, Insight and Exchange. And as a result, what we wanted to do is to create what we call the Insight Arena. We believe there's a heck of a lot of good work going on here. And that's from all different manner of stakeholders within the sector and that with the energy sector as well. And therefore creating some form of facility to share ideas, knowledge, insight, requirements around what open energy data should look like is something which we really embedded to do, and we've been working with the Energy Systems Catapult to be able to develop that. Workstream 2, which we called Realise and Test, is really about developing a prototype. And this includes the relative requirements for security testing, infrastructure establishment, as well as looking at different topics around modeling energy sector data, and providing as well some open source compilers which third parties can use as per the requirements of the bid and the fund. Now, we'll go into, in the coming slides, a few of the somewhat old interface presentation from the platform or prototype itself. But what I will also do is extend an invite for a session tomorrow afternoon, where we'll be looking to provide a little bit of a public overview in much more detail around the technology itself. And of course, as an outcome of Workstream 2, this is very much around testing the prototype, ensuring we have some third-party access to that, to the data itself, to understand what the challenges, problems, and successes are with the current approach. And then the third work stream, which we called Implement and Grow, is very much around the business modelling. Nothing comes for free, you know, working for a global OEM, that's always the case. We're interested in ensuring that structured and sustainable business is there, and not just for ourselves, but also for the energy sector. So really understanding what level of funding, what business models need to be developed to allow our initial vision to you know, open and extensible data exchange within the energy sector. How can we deliver that vision whilst also being cognizant of the fact that these platforms these services need to be supported financially and commercially. So we've been doing that and working with various different teams to develop our ongoing business model. And again, we'll come on to some of those considerations shortly. But as part of this wider picture within Alpha, what we also wanted to do is not just to you know, progress on the insight exchange and the discussions and what we'd call the data discovery activity, and then develop the platform itself or the prototype. We also wanted to see how some of the information we could get access to could actually start to encourage and incubate and develop ideas and innovations from third-party SMEs. So we also ran a very small innovation competition to encourage third parties to come up with new novel ideas of how we could use open data from the energy sector to solve future problems or to develop new services. And again, that will be something we'll be providing a little bit of a deep dive on tomorrow during the session. So over the next few slides, we'll talk a little bit in depth of the three work streams. And work stream one, as we mentioned, is very much around that understanding the data landscape piece. As you said, there's two core roles here. There's those who are providing the data publishers, understanding from themselves what is their user needs to publish this information. How are they going to make it public? What's the license that they need to share that information under? What format is the information? What interfaces can they support in terms of data sharing itself? What are the data structures that the information is currently held in? And what standardization philosophies does that underpin, if any? And let's not you know, let's not overlook the fact that a lot of data exists, but in many different forms without typically an overarching standard. Now, the data users themselves are those who are going to hopefully utilize this information to develop and extend new services. All of this is on the backdrop of a net carbon zero transition, and really understanding how we can reduce and remove silos to support new and existing users of data to develop new business models, new concepts, new services is very much part of the MEDA aspiration. And we saw this as very much a collaborative effort. Regardless of Siemens' role and the wider success of the YODA or Your Online Digital Architecture service, we see this as being one part of a much bigger ecosystem of data services. There, you know, to use the Lord of the Rings terminology, there won't be one ring to rule them all. And we know there's already a lot of good work done. You know, that the London data store, the Newcastle, Manchester all have their own iterations as well from a municipality perspective. But there's also third-party activities in energy as well. So how can we make the most of what's already there to provide that increased level of data exchange? So what we did, and we'll come on to the user stories, but as part of the first phase in the program, what was called the discovery phase, and the engagement that we had, which I've already mentioned, we were able to form, on the back of a lot of the feedback from the users, we were able to inform and develop 3 core user stories. And those user stories then framed types of data which we would like to get access to as part of this alpha process, which we've been undertaking with the Energy Systems Catapult. And then finally, we've also been looking at a common glossary of terms. So we mentioned likes of hygiene factors. There's a lot in this. You know, as a good example, depending on how, as a substation, you know, keeping it very energy centric, how people may reference substation. Is it spelled out substation? Is it SSN, SSTN? There's a whole host of shorthand that could be utilized in terms of data store within different organizations and activities within what is a pretty consistent landscape in terms of assets within the energy sector. So trying to come up with a common glossary of terms, and again, keeping that very open and collaborative is really quite important. And that also helps build upon any overlaps and gaps between different standards and and user behaviors as well. So the three core user stories or use cases that we were able to define based on that kind of rich feedback, and again helping us support and identify and focus, because the key challenge we had is Alpha itself is 3 months. This concludes at the end of November, at which point we will then be bidding to head into the third and final stage called Beta, which will start very early in the new year. So we wanted to ensure that the activity that we're going to do was focused, was ring-fenced, so was inevitably deliverable. And as a result, we came up with these three core user stories. So this one is really looking at how an OEM of any size, who itself has assets installed in this scenario through numerous different utilities, who doesn't necessarily have any access to, historic or certainly live data streams from that install base through numerous different clients. How could we potentially start to get information back to support these organizations in developing new functionality, or helping identify issues around condition monitoring, and help provide new roadmap considerations for functions going forward as well. In terms of the types of data that we thought may be helpful here, clearly electrical utility information is going to be critical. Looking at anonymized asset loading, historic time series data, for example, specific condition monitoring information, switching operations, oil moisture tests, etc. But even things around outage times and outage statistics, customer minutes lost, duration of these incidents, were all types of activity that we were trying to get access to during the course of the Alpha program. We saw that OEMs themselves or third parties who were looking to develop potentially condition monitoring type services could utilize this information, as part of a wider application developer. But also the utilities themselves could utilize this data as well. In terms of the second user story, e-mobility, as we'll all have seen and heard with the government's 10-point plan. E-mobility coming forward from 2035 to 2030 in terms of no ICE vehicles, new ICE vehicles being sold, is going to be absolutely critical to that wider decarbonisation commitment. So ensuring that there's a use case around the e-mobility topic was critical, and one of the pinch points as ever is the UK, is the infrastructure going to be there to now allow 60+ million people, or 30 million people, to actually access the infrastructure to charge their cars as freely as they currently can with traditional fuel sources. So in this scenario, how can a CPO, an operator of e-mobility infrastructure, expand its fast charging services in and around the UK, and what information is required to help them de-risk their business case and allow focused investment in the right areas based on supply, demand, and capacity? Well, again, the electrical utilities, unsurprisingly, are a key source of data. So where do they have existing capacity within the networks? Are there any heat maps available for network reserve capacity? What are the grid planning constraints looking? What are the grid planning assessments looking like going forward over a short to medium term? How can we bring back some of the DFES scenario data into this to support these organisations? But equally, how can we move away from the electrical utility silo to support bringing information around traffic monitoring? So what's effectively the footfall of vehicles? What's the utilisation of certain roadways for mobility patterns at respective intervals to maintain compliance with all the relevant standards? And again, e-mobility service providers, charge point operators, we thought would all be very interested in this type of data to help support their future service development as well. And then third and finally, keeping very much within the low or zero carbon commitment, we're looking at how onshore service providers in the renewable energy space may be able to utilize some of this data. So in this scenario, once more, looking at how, in particular, a solar or onshore wind farm in certain areas of the UK could potentially utilize this information to support with future investment planning and decision making. So, once more, electrical utility information, very critical, but how can we then potentially integrate Met Office data, weather, slope, irradiation information, Ordnance Survey, Environment Agency in terms of land use restrictions, infrastructure access, etc. And even local and district council planning, permitting, approval guidelines as well, to demonstrate where there is already potential capacity, not just from a connection perspective, but also from a planning permission perspective as well. So, you know, certainly not a small ask, but we're trying to bring as many of these various different data sets together and making those available to the innovators that we mentioned within the innovation competition as well, to see if they could start to utilize some of these data sets to develop new ideas and concepts with some small amount of seed funding. So that was Workstream 1 as an overview. Workstream 2 itself, really focusing very much on the beta development, or the platform development itself. And we came up with 2 core value propositions. The first being the energy broker, effectively a Google for energy data, very much a simple point and shoot. Frame a query, how many substations are there in Leeds? The broker would then search between all of the various different connected data sources and provide you a list of links, URL links, where you can go and access the data. The idea being this would be a very simple yet efficient service to provide increased levels of visibility, but also for us not to hold this information in a central digital twin, if you like, or data lake. One, to limit the management costs and the overhead associated with doing that on a significant scale, but also to ensure that it was as flexible as possible to reduce the cost to serve and hopefully provide a free or very low cost service to the market in that brokerage space. We also then saw a value in something which was much more specific and value added for the user itself in terms of a data collation value proposition. So this will build upon the brokerage service, but actually take the information itself, pull it through, and start to be able to model this on behalf of the requirements of the user itself. So in this scenario, how can we utilize metadata modeling techniques to pull this information into a form that's very user-centric, as well as building up additional value-added measures in this space as well. I'm conscious of the time, so I'll kind of just whiz into the third work stream. These just some of the screenshots of the of work stream 2. But in terms of Workstream 3, so very much looking at the cost and revenue models, well, we've kind of mentioned it's quite obvious that trying to do as much of this as possible in terms of a free basic service is going to be really impactful. And when we're moving away from any particular business consideration to seeing how we can deliver something for the greater good in terms of the net carbon zero transition, this is going to be really important. So the brokerage trying to keep a free basic service is core to our approach here. But how can we then open up different services in terms of the SDK to communities, developers, providing trial access to all of these areas on a on ring fence time access to the likes of the data collation value proposition as well, whilst also wrapping that into much more of a formal premium subscription, which can be utilized by organizations of all types depending on their particular need. Some of you may be aware of the likes of the MEDA competition. This is something which Innovate UK are running on the back of the MEDA initiative, and that itself is looking at how we can pull through this information or the available energy data, and then provided this to innovators to develop new applications. So the marketplace itself would effectively sit on top of this and potentially certainly pull through some of this information to support the new aspirations of these individuals. So really the kind of the formal call to arms at the time is looking at how we could access that real data, and this will progress certainly as we head into beta. And we will once again reach out to the market, not just to understand what data you have, but also how third parties, how users may look to interface with the system. And what sort of user stories, what type of use cases are going to be pertinent to you, your organization, and the energy sector as a whole, so we can go out and continue that data collation activity to find the right and the relevant data sets and come up with the right technical structures to enable that data transfer. User prototype testing is going to be a huge topic in the beta. It's going to be very, very key to ensure we can bring third parties in to give them access to the platform to run and test this open data exchange, and to ensure that it serves the needs of the market. We'll be able to utilize that feedback, that open feedback in that learning loop, to ensure we can consistently improve and refine the service for the mass market. And in line with the MEDA competition, it's really about stirring innovation. The data itself, in many scenarios, is a means to an end. The MEDA itself isn't the innovation. Opening up and providing visibility should enable innovation at scale in support of net carbon zero. So therefore, seeing how we can stir innovation as an organisation, how we can utilise this information, but more importantly, how we can work with, support and collaborate with third parties is of critical importance, and demonstrating how these new services can come to market with the support of open energy data is a real challenge, but one which we're certainly aspiring to support within the energy sector. So as a brief overview, that's kind of where we are. You know, we can see here there's a link on the website. We've got lots of different deliverables and data sources, etc., which we've been unearthing during the course of the program. Please, you know, get on this, reach out, read through some of the deliverables, and then if you've got comments, queries, questions, please don't hesitate to get in touch. As I say, we will be having a separate session tomorrow, and you're more than welcome to attend this. Perhaps we can share the registration link directly with yourselves as well, and that will be focusing very much on the technology itself, on the platform, on the modelling, and hearing some of the first-hand user stories from these organisations who've been utilising the information we found so far during the programme. So, you know, that's about it for me. Thank you all for your time. I guess if we've got any questions.
Thank you, Andrew. Thanks to the speakers. We are a bit short on time, but we could manage one or two quick questions. If anyone wants to ask, you could raise your hand or even unmute. Alison, I don't see any quick.
Not
Hi, Harris. It's Neil here.
Hi, Neil. Yeah, please go on.
Yeah, thanks very much. Thanks to all the speakers. That was really great. Could I ask either of the first two speakers, did I see on one of your slides that you were optimizing for cost, and there was a graph showing that indeed you did reduce the cost, but that had increased the carbon intensity of the operation? Is that,
yes.
Is that
so we can choose between optimizing for cost and optimizing for carbon, and a weighted factor between the carbon and the cost together. So this is actually for the choice of the officers, the estate's officers, so they could actually pick and do that and then directly visualize what that means, having chosen. And this gives, that's a really good point, because it shows the conflict of optimizing for cost and carbon, for particularly for CHP driven systems. And that has actually driven some of the discussions to show, okay, CHPs are definitely not going to give us carbon savings that we require. So things like heat pumps needs to be considered very early on. And that's what sort of University of Warwick, for example, is starting to do.
right?
Thank you, Neil.
Thanks very much.
Very quick question from Dr. Zoya Mirza, and perhaps a very quick answer as well.
Yeah, hello. Thanks to all speakers. There's a question for Andrew. So I would like to know, how do you envisage the trade-off between preserving data privacy and having an open data platform?
Yeah, no, so it's a good question. So when we talk about data privacy, if we talk about individual personal data, in many respects, I don't think that's envisaged really to share unless it's at an aggregated level, which is appropriate. You know, we know the DSOs have all been signing off or progressing their data privacy plans with the likes of Ofgem. And if we are ever looking at end user data, which, you know, more aligned with smart metering information, then that would obviously have to be held and managed through the existing DCC channels appropriately. If we're talking about network data, then I guess some of the privacy concerns are addressed from a personal level at least, but ensuring that the relevant security components are built in and baked into the system is going to be really quite important.
Okay, great, thank you.
Right, once again, thanks to the speakers. I would welcome a virtual round of applause. I think there's some option there, but thank you very much, everyone, for the very interesting talks, and I would encourage attendees to get in touch with the speakers or CESI if they would like to progress any of the discussions further. Thank you very much, everyone, for attending, and again, thanks to the speakers.